So again, this sucks. Because there's a 12 there. That sucks. Yesterday, we talked about the fact that if it was 4 terms, that would be relatively easy. Is it okay for me to say that? Do you guys agree with me that grouping is relatively easy?
Yeah.
And the word relative kind of pulls a lot of weight because there's harder forms of factoring, so that's relatively easy. I could break this up in a billion different ways. Negative 81 plus 82. Negative 81t plus 82t. Doesn't that make t? Doesn't that make t? Or negative 5t plus 6t. That makes t, right? You guys with me? I like it. What'd you guys talk about? Making t? Oh, okay. But none of that will work. None of that makes the grouping work. What are the correct numbers I want to use for coefficients? These two. If I break the middle term up to be 13t minus 12t, one thing is that makes 1t. So I didn't do shit today. I didn't do a damn thing. Nothing changed. That's still 1t. So you're all like, good job, Jeff. Way to go, buddy. But now there's 4 terms. So then I can group, yes? You guys kind of with me? What would come out of the first?
That's where I'm stuck.
No, come on. Does any number come out? No. How many t's come out? 1. So they each lose a t. Now look here. What comes out of both of these? Good. -1. And how do I know I'm on the right track? Right now, what would tell me something has gone wrong?
Both of those are the same.
Both of these are the same. That tells me I'm on the right track, because what's the only possible way I can go one more step is if something is the same. Otherwise, I can't do shit. So if this was a minus, you just forgot to take the negative out. Don't keep going. You can't. The only reason I could do one more step is because these are the same. Right? Are you guys kind of with me? If each term has the same thing in it, that thing can come out. That's all we're doing. It's just GCF again. So I can take this thing out. Why did I do this whole problem? I don't know, Jeff. And then what's left? T minus 1, yeah. It's kind of silly. Just cover what the hell you just took out. It's crazy. How do you check that shit?
Put a number in. And
you could put a number in, or FOIL it out and see if you come back up to this, right? If you have time. So on a test, if you get done and there's a few minutes left, you start going back and checking some things. All right, your first priority is to get something down for every problem. The only way to make sure you're going to lose all the points is if you leave a problem blank. And by the way, when I say that, I had people in the past just write down, I didn't want this to be blank, so I'm writing this. I'm like, that does not count. I mean actual work, right? Are you guys okay with that? So in general, if the first number is not a 1 and there's no GCF, I must multiply these together. This specific problem was easier than it looks because 12 and 13 make 1. It already kind of told me which numbers to use, right?
I had it down to that point, but I couldn't figure out what the grouping was going to be down there.
Oh, so you got to here, right?
Yeah.
So then these two, if there's no numbers, you're fine as long as there's a letter in common. The mistake people make is right here.
Yeah.
It looks like nothing can come out, but a negative can come out.
Yeah.
And of course, this is a big clue. You know you want this to show up here, and the only way this becomes this is if I take a negative out. Maybe? Is that all right? Okay. By the way, I need to remember to make the answer sheet for that thing. This is not your responsibility, but if anyone thinks to email me and say, hey, dude, don't forget to make that freaking answer. Maybe don't say it like that. That would be much appreciated. It's not your job, though. I still have to remember, but a little help is always good. What's up?
30?
30. Let me see. I don't want to say this. Let me show you an example like that. What's that one look like? Okay, we do this. You can do it, buddy. You could do it, Jeff. There it is. Okay. Jeff. So real quick, on the side. If it was this, what would you do?
Well,
That was it. We
I
moved this.
would take the squares of all those, because you got 4 is a square of 2, and b squared is the square of b, and 25 is the square of 5. So it'd be like 2b minus 5,
2b minus 5.
2b plus 5,
Yeah, why do they have to be opposite sides?
because otherwise you'd have to have an I in there.
No.
Because it is a middle term.
The middle term has to cancel.
Right, well that.
You guys going with me? Middle term needs to have opposite sign pieces so that it cancels, right?
Yeah.
Look here. 4 is 2 squared. 25 is 5 squared, right?
Yeah,
Did I do this right? I think so. We're going to find out. So, but the middle term is here, correct?
yeah,
So this might be a situation where the middle term didn't cancel, therefore these cannot be the different signs. I think I screwed up. Damn it, Jeff, what were you thinking about? Oh, I see what I was thinking about. All right, guys, let's salvage this a little bit. There you go, buddy. It's always exciting trying to make a problem up on the fly. So the trick to sum trinomials, when we're trying to factor them, if you notice the first term and the last term are perfect squares,
yeah.
but there is a middle term. It could just be like this, except these are not opposite signs.
It'd be plus and
If they're
plus.
opposite signs, no middle term. If they're the same sign, 10b plus 10b is 20b now, right? Now that I kind of
Yeah.
saved my ass a little bit, all right. I don't know if you guys get that. If you did not notice that, are you dead in the water? No. If you didn't notice that, what would you do? First number's not a 1. No GCF. What would you do?
4 times 25.
4 times 25, 100. Factors of 100 that add to be 20. Factors of 100 that add to be
5 to
20.
20. 5 times 20. Oh, I see what you mean.
10 and 10. 10 times 10 is 100. 10 plus 10 is 20. Break up the middle term. I mean, so again, anytime I show you, that's like a shortcut. If you happen to notice the first and last term are perfect squares, it might be easier. Even if you don't notice that shit, who cares? This method will work. Just you didn't notice the shortcut. You didn't save like 5 seconds. Oh, it's okay, right?
Okay.
And then you would just group. Is everybody with me? Right, what comes out of these two? What comes out of the numbers?
2b.
2, and then a b. 2b plus
5.
5. What comes out of these two? 5. 2b plus 5. What tells me I'm good? These are the
2b plus
same,
5
so
is
they
the
can
same.
come out. If they were not the same, I made a mistake. And I get the same damn answer we got earlier, just about 5 seconds long, right? So there are shortcuts. If you don't notice it, who cares? You still have a method that you know how it works, hopefully.
So
You guys
that's
got one?
like 30?
So again,
That's like 30?
that is like 30, yes. Because isn't 16 and 1, aren't they perfect squares?
Yes, they are.
And what's this, 4 and 4? 4 and 4 make
8.
themselves. Yes.
Would you want us to foil it or just leave it like?
Oh, be really careful. These say factor. Factor means undo multiplication. If you re-multiply it out, you'll just get back to where you started. So that's okay to check it, but dear God, circle that shit, because that's the answer, and then you can check it, right? Is that all right?
Yeah.
Yeah. So if the instructions say simplify, that means do the operations. That's when you would FOIL shit out. Factor means undo multiplication.
Okay.
You wouldn't redo it then, yeah. Yeah. I'm sorry. Question on one we just did?
I was late. This is a homework, right?
Yeah.
Okay.
45, this guy?
Yeah.
Alright. That's where things get trippy. Oh yeah, I'm just gonna stick over here so I don't have to keep moving the camera. Dual wielding. Okay. 40. Oh yeah. Okay. Beautiful. If this is the kind of problem that this is one of the few that gave you troubles, you're doing fantastic. So let me build up to this. You ready? So you gotta love this shit. Look at the problem, and look at what I'm doing. Oh, it's so good to be evil. There's a point. I'm sorry. There's a point to this. How do you factor this? What would you take out?
2x's.
X squared, right? I know what you mean. Don't you always take out the smallest power? Because that's the most you can take without somebody freaking out, correct? Okay. So that an x squared will come out and be 1 plus x cubed. Is that cool? Okay, so that problem's done. Whee! What about this problem then? Our brain kind of goes, because we see fractions, but you say, brain, calm this shit down. What's the smaller power?
Take out a half.
Take out x to the 1/2, right? What's x to the 1/2 divided by x to the 1/2?
1.
1. 3/2 minus 1/2 is a whole x, yes? Is that cool? 3/2 minus 1/2 is 2/2 is 1. It's exactly the same process. We know there's fractions there. Math is like, do the same shit. All right, math, fractions, give me a minute. Well, I do the exact same thing, correct? Now we're ready to take the next step. So what if I had this? What's the smaller power? They both have x's, don't they? So they're common. What's the smallest power? You all agree with me? We would always take out the smaller power so we don't... If we try to take 5x's, he's going to freak out, yes? All right, so what's the smaller power?
Negative 1/5.
Negative 1/5. So let's take a negative 1/5. I'll do the first part. I'll do half of it. That divided by that is 1. Okay, I did my half. What's... That's so funny, Joe. What do you do when you divide like bases? What do you do with the powers?
Subtract.
You subtract them, yes? I love you guys. You guys with me? Why was this 3? Because I had 5 minus the 2 I took out, 3 left. So what's going to be here? There's 4/5 minus the negative 1/5 I took out.
That's a plus.
4/5 plus 1/5?
Is 1.
A whole x, yeah.
Yeah.
Right? Again, this is really good right now. I want you to, I'm going to say this a lot maybe, I don't know, I normally say this. The processes of math don't give a shit what's in there. We do, because that wasn't as easy as this. But math does not see a damn difference at all between these two. Good for math. But what I'm trying to get you to understand is the process we used here, exact same process we used here. Do you guys see what I'm saying? We took out the smaller exponent and we subtracted the power we took out, we subtracted. We just had to go, oh, they're fractions, one of them's negative, but the process didn't change. Yeah.
Where are you getting the 1 from?
This here? Oh, this here.
That one.
Oh, okay.
Or just in general?
So,
Well, tricky, yes. The one.
okay, now real quick. If I took an x squared out, I'll get somebody to tell me this,
Okay.
but if you multiply that out, do you get this?
No.
No. So what are you really doing when you're taking something out? You're dividing it. Because when I put it in, I'm multiplying it.
Okay.
X squared divided by x squared. X to the 1/2 divided by x to the 1/2. X to the negative 1/5 divided by x to the negative 1/5. You always get, and you can also think of this as a placeholder, so that when you distribute, it holds this guy's place.
Okay.
Yeah. Yeah.
Alright, this is a stupid question, but like you do take the negative into consideration when you're, so when you're saying like which one's smaller, you do look at like negative.
Yeah, which one is smaller?
Alright,
And we understand our number line, if you go to the left, you get smaller, if you go to the right, you get bigger. So yeah, even if that was negative 100/5, versus 4/5. Negative 100/5 is smaller. Yeah. Okay, I like it. Okay. Anything else from homework? I appreciate all the questions because that means you guys are doing it. Yes.
I still understand.
45. Oh, okay, I'm sorry. So looking at 45, get out of the way now. This is one level up, you're right. 2c plus 3 is acting like x. How many 2c plus 3s? What's the smaller power? Why didn't you move, Mouse?
Well, minus 1/4 is the.
Yeah, negative 1/4. So I'm going to take 2c plus 3 to the negative 1/4 out. Right? So let me do, let's see. So if I had, make it two, that's a little similar, but I don't care. What's the smaller power? Negative 3/4. So I'm going to take this out. So what's left in this first term? X. Right. Over here I have a 2. What do I do?
Plus.
Yeah, 1/4 minus negative 3/4. So I add 1/4 plus 3/4 is
4/4, which is 1.
yeah.
It's a whole.
So it's a whole one of these.
Yeah.
And then in this problem, you have one more step because you can distribute this, right? Just clean up the inside. So again, notice math doesn't give a shit if this is x or if it's 2c plus 3. As long as it's the same base, you can do the same thing. I understand that for us, 45 looks a lot worse than the first problem I had up here, right? But the process, was that from outside? The processes we use, oh, okay. The processes we use don't change. I don't know if you guys see what I'm saying. This problem we did. You do the exact same thing for this problem. It's just that the parts are a little worse. There's fractions, there's negatives, it's not just x. But the process doesn't change. You take the smaller power out. When you divide something out, you subtract the power. I mean, it stays the same. Okay, maybe. 45 is definitely like the hardest kind of, how do we call it, grouping, like not grouping, but GCF kind of problem. But I hope maybe I've shown you that it's not as bad as it looks at first. Okay. Maybe, okay. Anything else from homework stuff or generally? Yes. Sorry? 43. Oh, this guy. Okay. Okay, let me say a couple things. This is kind of funny to trigger this. There will be tests where I let you use a calculator on part of it, and you can't use a calculator on another part. You guys all with me? This problem, use a freaking calculator. The thing you have to identify is what form is that in? How many terms are there? How many terms for number 43? 2. Don't worry, if it's not assigned, I don't care. You guys can ask me whatever question you want. There's 2 terms. What could it be? Either squares or cubes. What tells you it's cubes?
The fact that there's 3.
The fact that there's cubes. There's no GCF, correct? Do you guys see 125? Which, by the way, as a math person, the 8 and the 125, they're both cube numbers. So I'm like, ooh, 125 is a cube number. I gave it away. What do you cube to get 125? What do you guys think? 5. 1728. I don't know. I'm standing here telling you right now. I don't know. So do it in the calculator. Nothing wrong with that. You've done the important work. You identified what form it's in. Now it's just about breaking down each piece. Do you guys know how to do the cube root of 1728 in your calculator?
Yeah.
Okay. I think if you hit the math button even on your TI, there's a cube root symbol in there.
Yeah.
Or you could just do 1728 to the parentheses 1/3 power. Right? 12. Okay. Now I feel silly. I should have known that. Too bad.
So it would be like 5 power plus 12.
Yeah, so little dude, big dude, right? Yeah. Okay. So I'm going to get back into, actually I'm going to show you this video. So I got to stop recording or else I get a copyright strike. YouTube's. All right. Yeah, take the square root, right?
2i, right?
You got it. So this tells me what to do. I want to get x by itself, so I want to kill the square. What do I do? Does anybody have it like second nature? The minute I put a square root down, what do I have to put here? Plus or minus. Because tell me, real quick, just tell me, what do you square to get 9? What do you square to get 9? Or?
-3.
So every time you take a square root, you put plus or minus because there's 2 options for what could happen, what could work, right? So then I get plus or minus, square root of 4 is 2, square root of -1 is I. Maybe. To really blow your mind. Well, first thing, this does not blow your mind. How do you factor x squared minus 4? Can somebody factor x squared plus 4, please?
X minus
You're gonna have
2i,
middle stuff, aren't you?
X minus 2i,
and x plus 2i.
x plus 2i. Of course, that relates to those two answers, yes?
Oh.
You guys see that? Okay, maybe. No? Real quick. Do you agree with me that the middle terms will still cancel, yes?
Oh.
Now, real quick. So the middle terms cancel. Is everybody cool with that? First term, you get x squared. Then I get -4i squared, correct? Right? And what is I squared?
-1.
So don't I get x squared minus 4 times -1? Yes? So if you know how to factor x squared minus 9, you immediately know how to factor x squared plus 9. You just throw some i's in there. Okay, maybe. How you guys doing? You feeling all right? That's basically the extent to which I need you to know how to work with these things. Now let me say this. There's a difference between imaginary numbers and complex numbers. Does anyone know what complex number refers to?
That's a sum of like a natural number and a.
Yeah, so some examples of complex. You're right. It's got 2 parts to it. It's going to have a real part and an imaginary part. So this is a real number. That's an imaginary number. If I make a combination of them, I get a complex number. Every number you've ever seen is a complex number where the coefficient of the I was 0. So 11 is 11 plus 0i. It is a complex number, but it's more specifically just real. 4i is a complex number, but it's more specifically just imaginary, right? If I have a 7 plus 4i, complex. You got both. I don't know. You guys feeling all right? Okay. All right. So let me ask you this. What do you think 7 plus 4i plus 2 minus 3i? If I have those 2 complex numbers, how do you think I add them? You can do it. You can do it. What's your gut tell you? Treat I like a variable. What's x, by the way? In general, what's x? Value we don't know, right? What is I?
It's a value we know.
It's it's square root of -1. What is that? I don't know.
Oh.
So that's why they're going to act like variables. So how do you add these? 7 plus 2. 9. 4i minus 3i. Done. What about this? What do you got? What 7 plus 4i times 2 minus 3i. Take a minute and try to do that. So you can just go with your gut. Go with your gut. And you're like, my gut tells me not to do this problem. Okay. We can go, we treat I like a variable, but there are places we can go further. So on the first go, what do you get?
Negative 13i.
Oh, don't tell me the answer, tell me the steps. So here I'm going to get 14, right?
Negative 21.
Minus 21i
Plus 8i.
plus 8i
And 12i squared. Or negative
minus 12i squared. I love it. So on just surface level, it's just as if it was an x, right? So then I go, okay, 14 minus 13i minus 12i squared. But if you stop there, you're wrong because there's part of that we know. What part of that do we know?
The negative 12i squared.
Yeah, what's I squared?
Negative 1.
Negative 1. Now, I'll get people that suddenly start replacing I with negative 1. That's not true, right? I is not negative 1. I is square root of negative 1. That's what I do be. So here it would be 14 minus 13i minus 12 times?
12.
Negative 1.
Yeah. So you get 14 minus 13i plus 12. So then you get,
Negative 13i.
okay, negative
Well, I see what
13i
you're doing.
plus 26 or the other way around? Yeah. So the first few steps up to here was exactly like any other foiling problem, right? It's just the fact that it's I, not really a variable, that we can go further.
I was just kind of jumping ahead because you're minus 1 here.
No, I'm with
you're
you.
Minus
Yeah.
there.
You were multiplying in your head,
Yeah.
but I want to make sure everybody sees where it's coming
Okay.
from. Yeah. Okay. Yes.
I cubed would be negative 1, right? No.
I squared is negative 1. So if you multiply both
1.
sides by I, you get I cubed is negative I. All right, so
So you can, oh, okay, I see, because it's times 1.
and this is important because I actually want to do one more thing with that than we did the other day. So please let these problems be relatively easy. The first few steps is shit you've been doing forever. There's just one more step you can take. If you see I squared, it's negative 1, right? So real quick, I to the first is I. Way to go, Jeff. I squared is what?
Negative 1.
I cubed, if I multiply by I, what do I get?
Negative I.
Does everybody see that? If I know what I squared is, how do I get I cubed? I multiply by one more I. Okay, I like it. And then how do I know what I to the fourth is?
It's 1.
I multiply by one more I, right? Negative I times I. Negative I squared. Negative 1. I'll come back to 1. Jeff, you can do it, buddy. I forgot one. I to the 0 is 1. So I'll come back. There it is, buddy. Come back to 1. Let me stop for a minute. You guys all remember that? Anything to the 0 power is 1 except for 0. 0 to the 0 power is funky. So we won't talk about it. You'll see that in calculus if you take it. So real quick, let me see if you guys can get this. What is I to the 13th power without going all the way there? Can somebody figure out a shortcut? Yes? Why? How often does it restart at 1? Every fourth one. So I to the 8th would be 1. I to the 12th is 1. You guys see every fourth one it comes back. And again, remember, it's all based on 1, 2, 3, Jeff, 3, 4. Every fourth one, it kind of restarts, yes? So I to the 13th is I to the 12th times I. I to the 12th is 1. Because every fourth one, it comes back to 1. So that would be I. So a shortcut is, what if I ask you what I to the 406th power is? Right? You go, screw you, Jeff. 4 goes into 4. Does 4 go into 406?
Yes.
Well, 4 goes
Not
into
perfectly.
4.
4 goes
Well,
into 404. Error.
Yeah.
Right? 404. So how many's left?
2 more.
2. I don't have to actually divide. I just have to think how many would be left. So this is equal to I squared. Every fourth one it starts over. So the answer is based on what the remainder is. How much further did I go past 4? So this was 1 past 4. It's the same as I to the first. The answer is I.
So it's 1 times -1.
So it's I squared. What's I squared?
-1.
-1. All right. I don't want to spend a ton of time on that because that's not excessively important, but it's kind of important. What's the most important up here is this guy. Because that's the trickiest thing ever, right? We're so used to, if you square it, it's positive. No, well, if you use real numbers, yeah. Okay, maybe. Oh, y'all look very excited. Okay. All right. So all I'm going to say about complex numbers for now, you got to get in that homework and try it out. Okay. Anything about what I have up here before I erase it?
It's on the video, right?
Totally. That sucker's going, right?
I hope so.
I hope so. Yeah. All right. By the way, just like reminding me to do the answer key is not your responsibility, but I would appreciate if you did. If anybody's in the front row and you notice the sucker stops, maybe it takes a union break. It'll do that sometimes. Just let me know. Yeah. All right, so what I want to spend the rest of the day on is talking about solving quadratic equations, right? Then we might get a little bit into 3, we'll see. So what do I mean by that? So here's like your standard little quadratic equation. What do you got, Jeff? I don't know, dude. Oh yeah, let's do that. Let's do, sure. Can you solve this for x? The way it is, can you solve? If that wasn't there, could you solve that for x?
Yes.
Shit, yeah, that would be an awesome problem, Jeff. Too damn bad. We don't have. So why can't I not solve this for x? Because can you combine all your x shit into one term? Why not?
Because 1 squared.
Yeah, they're not like terms. Damn it. So we have to kind of develop a way around that. I want to point something out that was in that video because it comes up later this semester, but the fundamental theorem of algebra is a true thing. The highest power in that is 2. There must be 2 answers. In general, they could be complex, it could be real, it could be repeated, right? But there must be 2 answers. Are you guys kind of with me? Okay. Does anyone know how to solve this?
Would you square root it?
You can't. Because if you square root one side, you have to square root the other
Yeah.
side, and you get a lot of shit in there you can't do anything with. You can't square root a piece.
Factor.
Factor, I love it. So let me say a little side note. If I tell you that, all right, you ready? I'm thinking of 2 numbers, and they multiply to be 8.
2 and 4.
That's not right.
They multiply to be 8.
Yep, multiply to be 8.
Get in
1 and 8.
Nope, that's not right.
1 and 8.
Still not right.
They multiply to be 8.
They multiply to be 8. 2 numbers. I did not say 2 whole numbers. So I'm thinking about 16 and 1/2. Do they multiply 8? What? How many answers could there be? How many numbers?
Infinite.
Negative
You guys
8,
would-
negative 1.
Huh?
Negative,
That
negative,
also.
negative.
So how many total? Infinite number. Yes? If you don't believe me, 80 times 1/10. 800 times 100th. I could just keep going there and get an infinite number of answers. Yes? Do you guys kind of follow what I'm saying? So if I have a number times a number equals 8, or anything, any number like that, infinite number of answers I can't answer. I don't know, shit. Now I'm thinking of two numbers that multiply to be 0.
0, 0.
One of them has to be
0.
0. So we know something then. If they multiply to be 0, we know something. One of them has to be 0, yes? And then the other one could be whatever the shit it wants to be. Right? As long as one is 0, the other one could be anything funky as hell. It could be 7i minus the square root of 20. Woo. All right. So what's your point, Jeff? I don't know. Oh, yeah. If I had this written as one number times another number, I can then just set each one equal to 0 because I know one of them has to be 0. So how do I factor this? See if Jeff made one that works.
It does.
Good. Thank you. What's 5 plus 4? What's 5 plus 4? 9. So I know 9 goes into 54. Do you guys know that? Real quick side note, and hopefully this is okay. I do a lot of side notes, but they're all like related to what we're talking about. If I have any number and I add up all the digits and they add to a multiple of 9, the whole number is divisible by 9. Did you guys? Did anyone know that? A few of you guys did. Do some of you guys think you've never been told that? Okay. You should be a little mad.
Minus 9 is
Right?
6.
So for example, real quick. For example, 1, 4, 5, 2, 7. What do you got just so far? What is that? So then,
19.
wait, 8. Okay. If you add all those up, what do you get?
No idea. 10, 12, 10.
27?
27. Is that a multiple of 9?
Yes.
So the whole thing is divisible by 9. Somebody help me out. Take that number divided by 9. Somebody, please, help me out. I haven't gotten my implant yet. I want to get a calculator implant. Not really. I don't want that shit. That would be weird. Good to meet you. What the shit?
16, 142.
Yeah, so it goes in evenly, right?
Yeah.
Okay. You guys okay? So that's neat, yes? How many other numbers are there rules for? 3 has the same rule. Why does that kind of make sense? Because 3 goes into 9. So if I add up all the digits of any number and the answer is a multiple of 3, 3 goes into it. You guys know what works for 2. What makes a number divisible by 2 is just a even number. What about 4? Even doesn't work for 4 because 4 does not go into 10, for example, right? If the last 2 digits are divisible by 4, if the last 2 digits are divisible by 4, the whole damn thing is divisible by 4. Isn't that kind of neat? Isn't that good to know? I know we invented calculators, but we're humans. We should know shit about the stuff we made up. We made all the shit up. We should kind of know how they work. I'll stop. Okay, coming back. I'm sorry. Coming back. Why did I say all that stuff? Well, I know 9 goes into 54. 9 times what? 6. And sure enough, 9 and 6 are 3 apart, yes? Which one's going to be negative?
9.
9. So then what do you get? If I said x minus, so I've got one number times another number is 0. Either this number is 0 or that number is 0.
Yeah.
It's positive 9 and negative 6.
Yeah. If that was an 8 or anything that's not 0, I could not do that. Why? Because there would be an infinite number of possibilities. Oh, if it's a 0, only one thing. One of them's got to be 0. Do you guys get that? Do you guys remember doing this? Yes.
But it can't be divisible?
Say again?
It can't be divisible?
Well, x cannot be more than one thing at one time. But if x is 9, this is 0. This is 15. Does it matter that this is 15? No, because that's 0. If x is negative 6, this is 0. This is 3. That doesn't matter because one of them's 0, yes? Do you see what I'm saying? Okay. All right, so one way to solve a quadratic equation is by factoring, right? Now you guys know where we're headed. What are we eventually going to get? What if I couldn't factor that?
Quadratic formula.
Right. Yeah. Right, so before we get there, I have to tell you about something called completing the square. Has anybody ever heard of completing the square? Okay. Real quick, by the way, I'm sorry. Anybody concerned about why this is called quadratic when the power is 2? Quad makes it sound like there should somehow be what involved? 4, yes? If I had a rectangle that was x plus 6 by x minus 9, doesn't it have 4 sides? What would the area be? This times this, yes?
Yeah.
So that is actually, however you feel about it, that's why they call it quadratic. I personally think it's dumb, but oh well, too bad for me. I wasn't around, and they were all high on something, so. Okay. I have a handout I'll give you in a minute. But I want to lay down the ground rules of this idea. Has anybody ever heard that phrase, completing the square?
Yeah, I've heard of it, I just don't know what it means.
Gotcha. Yeah, it's not. I'm not going to give you a picture, and then you're going to go, let me draw this in. I completed. No. So, it was funny. Okay, sorry. Here's the idea, real quick. Somebody help me out. Yeah, everybody agree with me? That's a square. That's a perfect square thing, of course. When you do it, what do you get? When you multiply it out, you do not get x squared plus 25, correct? You get more than that shit. Can somebody take a second and tell me?
X squared plus 10x.
Beautiful. X squared plus 5x is 10x. How does this relate to this? How does that number relate to this number?
It's
5
double.
is- Or 10 divided by 2 is 5.
5 plus
So 5 times 2 is the middle number, yes? And how does this number relate to this number?
It's a square,
5 squared is this number.
yeah.
Okay, let's try another one. X minus 4 squared, what do you get?
Oh,
x
16.
squared minus 8
Yeah, minus 4 minus 8x.
or plus 16.
Yeah, right, so just to make sure you guys understand, we're just doing this here, right? So
Yeah.
you get x squared minus 4x is minus 8x plus 16. How does this relate to this?
It's double,
Yeah, this is twice negative 4 is negative 8. And how does this, Jeff, you can read, how does this relate to this?
square.
Yeah, this is negative 4 squared. Every damn time. I don't care. Now, do you guys agree? I don't have to do every number because it's just going to work the same damn way. I'm going to get 2 of the middle and the square on the end, right? So, if I gave you an incomplete square, what does that mean? I don't like you. Go away. You are a powerful freaking magnet. Okay. What if I gave you this? X squared plus 6x. What would I put here so that I can factor it like this?
9,
So here's the steps. Remember the middle term? Damn it, Jeff. The middle term, this works. The middle term was twice the number that's in here. So the first step is divide the middle coefficient.
yeah.
That actually is what goes here. I really want that to make sense. I wish I wouldn't have erased this damn thing. All right, there we go. If I cut the middle term in half, isn't that the number that's there?
Yeah.
If I cut the middle term in half, isn't that the number that goes here?
Yeah.
Cut that in half. That's what goes there. How do I get the last number? I take that,
Square.
square it. So yes, if I add 9, it then factors. I have completed the square. I've made it so that I'm able to write it as something squared. And you're all like, good for you. How does that help me? Okay. So if I had a problem like this, that's nice and gross. I love it. And actually, okay, don't write this down. Side note. How do I solve this again? square root, and I have to remember plus or minus, so then I get x equals plus or minus 3. How would you solve this? I would still square root plus or minus. So then I get x minus 7 equals plus or minus 4, and then I add 7, blah, blah, blah. Blah, blah, blah. So if I can make this side become something squared equals a number, I can just square root both sides. So what do I put here?
16.
Yeah, so half. So the first step is cut the middle coefficient in half, and that actually is how this factors. This kicks so much ass. I got a little handout, by the way. You said it right. I'll do it. The funny thing is, the first step tells you how this factors. The second step, what's the second step?
Square.
Take that number you got and square it. That tells you what you have to add here. If I add this here, I better freaking do what?
Add to your side.
Freaking true. Okay. So then I get. Well, I kind of like that. I didn't mean that to happen, but. The answer's going to be a little gross. It's going to be a nice little you can do it, Jeff, review of something. What do I do now? Why did I do all that? And you're like, I have no idea why you do anything, John. What can I do now, just directly? Square root. I better put
Plus or minus.
yes. So I get x minus 4 because these kill each other, yes?
Yeah.
I like it. And over here I get, what is the square root of 27? Does anyone know?
No.
Can anybody approximate it for me? What's the square root of 20?
Slightly
What's the square root?
more than 5.
Yeah, a little more than 5. Because square root of
5.9.
25 is 5. I don't know. Calculator, I don't give a shit. Sorry. Thank you, though. we're humans, don't want it. Huh? It's like 5 point something, right? You guys with me? But I don't want to see that shit. You can never give me the exact right answer for a decimal that never ends. Yes? So a much better way to write an answer is not in a decimal form. Does anyone remember how to simplify this? Is there a part of 27 I can do the square root of?
Oh, can't you do 9 times? Oh, wait, no, sorry, not 9.
5.
Yeah, 9 times 3, and then it's 3.
Right? Isn't square root of 9 times square root of 3 square root of 27?
Yeah.
Half of 9 times half of 3 is half of 27. Does everybody agree? What's the square root of 9?
3.
3. What's the square root of 3? I don't know.
3 radical 3.
And then I just have to, what's the last step? To solve for x.
Plus 4.
Add 4. So I get x is 4 plus or minus 3 rad 3. Now, that is not quadratic formula, correct? What we just did is not quadratic formula. But doesn't the answer look like something you would get from quadratic formula?
Would it be the same to say 3 to 4/3?
Oh, where are we at? Yeah. No, 3 to the 3s. Because it's a square root. 4/3 would be a cube root. This is a square root. But I don't want it like that anyway. I want it like this. Yeah.
Okay.
I think does that seem familiar to anybody? Yes.
So when you went from x squared minus 8x plus 16 down to the square root of x, how did you get that? How did you get that?
Well, if I factor this,
Okay.
what two numbers multiplied by 16 had to be negative 8?
4.
Negative 4. But the beautiful thing, that tells me how that's going to factor. That's crazy. I don't even have to factor it. I just put that number there.
Okay.
But if I did factor it, it would be this. Of course it would be, because that's how we kind of like built the process to work. Okay. So this is what math is. We identify patterns and then we force it to do what we need to have happen. We saw a pattern. Yeah, now we can force it. Yeah, I can make you become a square. Right? Okay, all right. Now, I'm going to show you something you don't want to see, and I don't care. I'm going to show you where quadratic formula comes from. Does anyone think they've ever seen that? Like, if I ask you what quadratic formula is, could you kind of try to tell me? Does anyone remember parts of it?
Yes. X equals negative B.
You're thinking about linear equations. You're thinking about lines. I'll start us off. Negative b plus or minus square root of
4 times A.
almost b squared minus 4 ac. Okay. That's a bunch of shit. So,
Over 2A.
yes. You do not have to write down what I'm about to do. You can if you want to. I think it's in the book. I can't remember. But I want to at least one time show you where it's come from. If you've seen it already, just sit there and suffer through it. I'm sorry. You're all going to be very excited about this. By the way, I think before I do that, let me do... Why was this problem relatively easy? Because didn't I put an 8 in the middle? And you can cut that in half easy. All right, so before I show you the derivation of quadratic formula, let me give you a worse example of that kind of problem. So what if I gave us this here? Okay. Can you factor that?
No.
No. Do we officially know quadratic formula yet? No. Right? And in fact, on a test or something, I would say, solve this using completing the square. Right? First thing is, don't I want this to be blank? So let me add the 2. Get out of the way. Right? Blank. All right, so what are the 2 steps?
Divide by 2 and square.
Take the middle term, divide it by 2,
3.5.
then square it. What do you get when you square it?
12.25.
No, I don't care. I don't care about decimals. What do you get? You get 7 squared, 49, 2 squared. 4. Okay. You'll see why in a minute. Does anyone remember what goes where now? Where does this go? I'll tell you where to put it, Jeff. No, stop. Where does this go?
Okay, so
That's what I add to both sides.
top one's the exponent, the bottom one's the root.
It's not a power.
Oh,
It's just a number. It's just a fraction. Yeah.
okay.
What does this tell me? Now, do you want, if I gave you this, do you want to factor this? Do you want to factor this? No. The nice thing is you don't have to. What do I know goes here?
3.5.
7 halves. Let go of the decimal.
Sorry.
You're good. You're good. I don't blame you. Most often in this class, and nothing's wrong with 3.5. Real quick, if I was like, how far do you live away from the school? And you said 7.5 miles, I'd be like, what the shit's wrong with you? So if I have a word problem, I want the answer to be like a decimal, so we talk to each other like normal. Even a decimal, you would say about 3 miles. You wouldn't say 3.18746. But for a word problem, you could put the decimals. For a math problem, I want the exact answer, which very often means leave it alone. Right? Don't make it a decimal. Yeah. How do I add these together? I need a...
You convert the 2 to fourths.
Yeah, so I multiply by 4, I get 8 plus 49, I get 57 fourths. Is that cool?
Yeah.
Okay.
Turn it into a whole number with a fraction on the side.
Say again?
Turn it into a whole number
No.
with
We don't want to mix them. We stop for a minute. This is a really good example of what I talked about earlier. Numbers are gross. Yes, these numbers are worse. The process doesn't give a shit. The process says take the middle, cut it in half, and then square what you get, and then put the stuff in the right place. That did not change at all. And the really kick-ass thing is, how ugly this is doesn't matter because I already know how to factor the damn thing. The first step told me how to factor it, yes. Oh shit, what time is it? Okay. So I just remember we're going to go on a field trip. Yeah, all right, I'm going to finish this up and then we're going to go. Square root, right? That was the whole point, to try to get it to here. What's the square root of 57? I don't know. What's the square root of 4?
2.
2. And then I can subtract 7 halves. And I can actually put it all together. Doesn't that look like an answer you would get from quadratic? So all quadratic formula is it is a shortcut to this. And to be really honest, This is actually less long sometimes, right? So here's how this is going to happen. I'm so happy I just remembered. We're not going to go very far. Everything's in this building. I was thinking about taking this out to the financial aid and all that kind of stuff, but if anybody does everybody know where admissions and counseling and financial aid, they're all in the main building next to the quad? Okay, I'm not going to make this march out there. Everybody kind of like pack up, get off the door, and kind of start going that way slowly. Let me catch up and get in front, okay? I'm going to shut things down and stuff. Are you with me? Oh man, I forgot to give you guys this. Here, real quick, sorry. I'm going to give you guys this here. Someday I'm going to remember everything. Here, guys. Go out the door. Slowly. Guys, you guys. I don't know why I didn't print out. So I'm going to end up in my office. I can print this out if you want to, or just wait for tomorrow. Arg.